Okay? Hello. Hello to everybody. My name is Beatriz Mañas Ballester, and I work as Business Development Manager at IBV. IBV is an R&D center located in Spain, and we study the behavior, the human body, and its relationship with the products and services and environments. Okay? I'm here because we are promoting MOVE4D, which is a 4D scanner. Unfortunately, I cannot make a demo because it's a huge system like a lab, but I can give you some tips and speak a little bit about what it is, okay? Here, you can see here, this is the sensor. So to be able to record and get the point cloud, we need minimum 12 of these. Each sensor has 2 IR cameras, 1 IR pattern, and also an RGB camera to get the texture. So with 12 modules, 12 of these, you can get a scanning space of 2 meters by 2 meters by 3 meters. To be honest, I didn't start saying what a 4D scanner is. At the end, 4D scanner is you can get the whole body shape of a person in movement, okay? So that's the reason we need a scanning space where you can have free space to make any movement freely. You also can extend the length of the lab, including much more modules as well. So we have 2 configurations, 12 module configurations covering a space of 2 by 2 by 3, and another configuration covering 3 by 2 by 3. This type of configuration can be adapted, okay, depending on the footprint that the customer has. So let's say that any installation is unique, because we start from the very beginning helping the customer to define the best configuration. Because I didn't say it, but with this module we can change optics, we can adapt it to the customer needs. Okay? So what do we get? Then we get, if we come here, so with this type of modules, we get the point cloud. That is the point cloud with more or less 4 million points. As you can see, the point cloud is very dense. But what we do with this point cloud is to process it and to convert it into an homologous mesh. So what is an homologous mesh? It is a mesh with consistent topology. That means with point-to-point correspondence along the sequence and across the subject. So let's say that any point that I said that has 50,000 points, any point from the mesh can be tracked. Could be the same, is the same, let's say, is the same along the sequence and across any subject. Okay? Also, you can see here the red points. So any point that you see here, the point 13,900, is going to be the same across the subjects and along the sequence. Okay? At the same time, texture also has pixel-to-pixel correspondence. So UV maps are also have the same topology as well, okay? Pixel-to-pixel correspondence. And on the other hand, we also provide the skeleton. This process is fully automatic. So we provide as output an OBJ or other type of format, let's say a mesh with point-to-point correspondence, with pixel-to-pixel correspondence, and totally rigged. Okay? On the other hand, we also provide measurements. measurements, automatic measurements in APOS, but also dynamic measurements. So dynamic measurements means measurements along the sequence as well. Okay, so once we have that 3D content, what can we do? So we can export that 3D content that we obtain, and we can export it easily with different containers into different platforms, okay? So there are plenty of different possibilities to export the formats as OBJ, mesh. Also, you also have the PLY. You also have the FBX of the whole sequence, but also you can export in BBH and in TRC, which is more for biomechanics in research, and also in GLB and GLTF, okay? So it has been designed to be easily integrated into different platforms and to help in the production pipeline, okay? And afterwards, you can export it, and then you can have it in, for example, in Blender, so very easily to integrate into platforms like Blender. I don't know if we've got some examples here, but it is completely rigged, so very easy to use. And I think that's it. I will welcome anybody that is there to come to visit us to Valencia, so we could make a proper demo, or even we can organize an online demo if it is needed from our own lab, okay? Thank you very much.